pick up. Okay, so today I will be teaching my cousin plate tectonics. So basically, the Earth is made up of layers, and then the inside there's the core and the mantle and the asthenosphere and the crust. So the crust is where we are right now, and then right under it is the asthenosphere, and it's like really hot there. So the asthenosphere is kind of molten and like not very stable, and so the crust is on top of that, and it's like really brittle. By the way, you can ask questions whenever you want. And the crust of the Earth is, since it's brittle, it's kind of separated into like different plates, hence the name plate tectonics. And this is a picture of the Earth, or a map of the Earth, and then it shows the outlines of some of the bigger crust plates. And because of the molten kind of consistency of the asthenosphere that the crust is on top of, it causes the plates to move. That's why there's arrows showing like kind of where the different plates are moving. So it's not always stable, and because of the instability, this causes lots of different activity between the plates. One of the types of plate boundaries, or where the plates meet, is a divergent plate boundary. And in a divergent plate boundary, the two plates are separating from each other. So this is the asthenosphere, and since it's hot and like molten, it's pushing up towards the crust, and the upward thrust is causing the two plates to go opposite ways, and it's like splitting up. And in this area where the plate boundary is, it's gonna cause some of the asthenosphere to come up, and it's gonna make new crust as it cools, because there's like an ocean on top of it, so it's gonna cool as it opens up. So that's one of the plate boundaries. Another plate boundary is a divergent plate boundary, or convergent, a convergent plate boundary, where the two crusts are coming together. So it's like this plate is being pushed toward the other one. And there's lots of different things that can happen in a convergent plate boundary. One is that the one plate is going to go down or subduct because it doesn't weigh as much as the other plate coming in from here. And that's going to cause something like a trench, an oceanic trench, because the Earth is going to go down in towards the asthenosphere. And then there's also an upward thrust from the other side of the plate, and that usually causes like mountains and volcanoes, mostly mountains. And the last type of plate boundary is a transforming plate boundary, where the two plates are kind of clashing against each other, like in opposite ways. Hold this. So this is one plate, and this is the other, and they're gonna go like against each other. They're gonna like rub against each other. That's gonna cause a lot of seismic activity, which means there's gonna be a lot of earthquakes in that region. An example of that would be the one that causes earthquakes. An example of that would be the San Andreas fault line. There's a transform boundary there. for trenches, an example of a trench would be the Marianas Trench, which is, I don't know, it's like a really big trench. It's like really long and it's really deep, deeper than some of the mountains we have now. And examples of mountains like Mount Everest, Himalayan mountain range. So there's proof of this everywhere in the world, including like if you made a map to show like the earthquakes or tsunamis in an area, it would look much like this one with the plate boundaries. And that supports the theory of plate tectonics because it shows that in these areas there's a lot of seismic activity, and if the theory of plate tectonics was not valid, then it wouldn't show the same kind of pattern than the one that's being shown here. Do you understand?
Yeah.
Okay, good. Thank you for listening.